In this session, we will discuss about modulus of a counter. Modulus of a counter means number of states or counting sequence through which a particular counter advances before returning once again back to its original first state. That means if a 2-bit counter, it has 4 states. That is 2 raised to 2. That is 4 states. That means modulus of that counter is 4. Okay. 0 0 0 1 1 0 1 1. That are the 4 states of 2-bit counter. If suppose the modulus of a counter is 8, means we have 3 flip-flop. 2 raised to 3 is 8. Modulus of a counter means 8. This is a mode 4 counter. Mode 4 counter means 4 states. It's a 2-bit counter. That means 4 states. That is 0 0 0 1 1 0 1. These are the 4 states. Mode 12 counter means 12 states. Mode 16 counter means 16 states. Mode 8 counter means 8 states. That is modulus of a counter. Now we will discuss about divide by n counter. This is divide by 2 counter. That is, here we are giving a clock signal, and the output of this flip-flop will be clock by 2, divide by 2 signal. This frequency, if we are dividing by 2, if we are giving 2 kilohertz here 1 kilohertz, the output will be 1 kilohertz. That is, from the timing diagram we can understand that here 4 clock pulses are there. That is, this is a clock given to the clock input of the flip-flop, and the output Q out will contain divided by 2. That is, here we are giving 4 clock pulse, means the output will be 2. That is divided by 2. That is divided by 2 counter. That means if you are using one flip-flop, the output will be divided by 2. That is clock frequency by 2. See, in this is mode 4 counter. That is divided by 4. This is the clock frequency. Clock signal input we are giving to first flip-flop. The output of first flip-flop will be divided by 2 of the clock pulse. The output of second flip-flop will be divided by 4 clock pulse. So if you are using 2 flip-flop, we can say that quarter the output of the clock pulse. That is divided by 4. If you are using a mode 8 counter, we can say that it is divided by 8 counter. That is, the clock frequency is given to the first flip-flop clock input. The output of first flip-flop will be divided by 2. Output of second flip-flop will be divided by 4. Output of third flip-flop will be divided by 8. That's how the division of clock signal occurs. Suppose, for example, we have a 60 hertz frequency signal, and if you want to divide by 6, if you are using divide by 6 counter, what will be the output? 10 hertz will be the output. If 60 hertz frequency is we are using divide by 6 counter, means the output will be 10 hertz. That's all about modulus of counter and divide by n counter.